All right. So that's our second example. Oh, grade exam 1, to be honest, I haven't looked at it yet. Unfortunately, I'm really not happy with myself about that. But unfortunately, I did not get a chance to yet. No. Thank you. Okay. I'm working as fast as I can. I really want to get it graded before Tuesday. I know they have like midterm reports or something to do then, so I'm hoping to do it by then. All right. Anyway, let's keep going. Hey, stop sharing. Up there it is. Just when I minimize it, it stops sharing. That's annoying. What are you gonna do? Anyway, we did this. All right. I just want to basically say what a deck of cards is. I mean, they do it in the book, and I figured it wouldn't hurt. So for us, when we deal with a deck of cards, we have 52 playing cards in there. And the cards have 4 suits. One of them is, spades, diamonds is another one, hearts, and clubs. So you can pick up a deck of cards. You don't have to, but you can. In Walmart, I'm sure has them. Or most stores do. Anyway, but I'm not saying you have to, but you could. Not expensive, though. And from each suit, there are 13 cards. You have cards numbered 2 through 10. Okay, so I don't think there's a card labeled 1. There's 3 face cards, Jack, Queen, King, and there's an ace. Now, is ace higher than a king or lower than a 2? I think it depends on the rules of the game, but for now, let's just keep it like this. And again, Jack, Queen, and King, those are face cards. This is for each of the suits here. So there's a 2 of hearts, a 10 of clubs, okay? And there's no jokers, though. I know some decks have jokers in them. We don't have jokers in this. We don't have jokers. There's 52 playing cards. Now, with that said, okay, let's consider this example. Again, we have a standard deck of 52 playing cards. I guess you can also assume that the cards are equally likely to be chosen at random. They're not marked or whatever, so what do you call it? They're not marked and stuff. What's the probability of choosing a king? Well, I'm not going to write out the sample space, but if you think about it, we really don't have to, right? There's 1 king for each suit. That's what I said here. There are 4 suits. Because of that, the probability of choosing a king would be 4 out of 52. Right? There are 4 kings you can choose from. Each king you choose would be, I guess, an outcome. Each possible king, I guess. So it's 4 out of 52. What about choosing a card that's a club? In other words, you're choosing a card from the suit of clubs. Well, we know each suit has 13 cards, right? And the club is one of those suits. So the probability of choosing any card that's a club is 13 out of 52. Okay? There are 13 ways we can choose a club. There's 13 ways that event can happen. You choose, 2 of clubs, 3 of clubs, 4 of clubs, and so on. Any one of those. And there's 52 outcomes altogether. Okay, so that's good. Now here's a fun one. What about this? How likely is it we're going to draw a negative 1? Well, is that even possible? Okay, let me do a poll then. Oh, someone said no. Another one said no. And it's no. Is there a card labeled -1? Well, the answer is no. Right? There is no card labeled -1. So even before going to the next slide, what do you think the probability of that should be? 0. Very good. Very good. Awesome. Okay. Right. So, there is no card labeled -1, right? Wait, am I still recording? Yes, and yes, they can hear me. Good. All right. Yeah, there is no card labeled -1. So theoretically, that probability should be 0 because it's impossible. And this actually brings us to, as you can see here, some more terminology. You can have events that are impossible, events that have probability 0, and there are events that are certain. Those are events whose probability is 1. You kind of saw from the definition that probability of an event is always a number between 0 and 1. With 0 and 1 are possibilities. For instance, with rolling a die, what's the probability we're going to roll a -10 if it's a standard 6-sided die? Well, from what we saw, you can't roll a -10, so that's impossible. That would be 0. But if we roll a 6-sided die as before, what's the probability we're going to get a number between 1 and 6? What's the probability we're going to get 1, 2, 3, 4, 5, or 6? Well, that's going to happen. That's a certain event. You have to get one of those numbers. So that would be a probability 1. Now, okay, now also, okay, we also like to denote, events by capital letters, mostly because, again, those events are sets, and sets we generally denote by capital letters. So you'll see, though, that events are generally denoted by capital letters. I wanted you guys to try this, but it's all right. Originally, I was going to ask you guys what's the probability of rolling, like a 3 and a 6. If we roll that 12-sided die, what's the probability of rolling a 5? I wanted you guys to try this, but unfortunately, looks like I have the answers here already. That's all right. All right. Anyway, so again, with a 12-sided die, right? We're assuming that the sides are labeled, 1, 2, 3, 4, 5, and so on up to 12. What's the probability of rolling a 3? Well, there's only one outcome there, right? Namely, rolling a 3. That's 1 out of 12. What about rolling a 5? Well, again, all the outcomes are equally likely, and so we also get 1 over 12. And we roll a -3. Well, no, that's impossible, right? So that's a 0. The event's impossible, so it's 0. For an even number, let me actually go back to, here it is. What about rolling an even number? Well, let's see. We have one even number, another, 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 and another. What is that? That's 1, 2, 3, 4, 5. Oh, for some reason I wrote 5 there. Okay. For some reason I wrote a 5 here, but it's not 5, it's 6. Right, mostly because in that event, how many outcomes up? That's a funny looking 6. Let me erase that. Mostly because there are 6 outcomes, right? With rolling an even number, 6 outcomes that correspond to rolling an even number. So we can roll a 2, a 4, a 6, an 8, a 10, or a 12. There's 12 outcomes altogether. So we get 6 out of 12. That's what we get there. Here are some more examples. This was good to do. Now, this one's a little bit different. So just read, I'll be right back. Just had to get. All right. So we're rolling a standard 6-sided die, just like before. This one's a little bit different. What we're looking at, right? We want the probability of not rolling a 2. Well, how can that happen? Well, as I wrote here, how can we not roll a 2? If we're not going to roll a 2, we have to roll something else, right? We would have to roll a 1, or 3, or 5, 4, or 5, or 6. So to not roll a 2 means we can roll a 1, a 3, a 4, a 5, or a 6. 5 numbers here. So the probability of not rolling a 2 is 5 out of 6. We know the probability of rolling a 2 is 1 out of 6. And look over here. This is pretty interesting. If you add up the probability of not rolling a 2 with the probability of rolling a 2, that sum is equal to 1. That's interesting. That sum is equal to 1. Let me just